Day 785 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3020. Find the maximum number of elements in subset. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of positive integers nums. You need to select a subset of nums which satisfies the following condition. You can place the selected elements in a zero-index array such that it follows the pattern x squared, x to the fourth, x k divided by 2, x to the k, x to the k divided by 2, all the way to x to the fourth, x to the second, x all again. Then it says, note that k can be any non-negative power of 2. For example, 2, 4, 16, 4, and 2, and 3, 9, and 3 follow the pattern, while 2, 4, 8, 4, 2 does not. Return the maximum number of elements in a subset that satisfies these conditions. All right, y'all, so that may seem a little bit confusing at first. So before we get into the solution, let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 5, 4, 1, 2, 2. The output is 3. Explanation says we can select the subset 4, 2, 2, which is this 4 and these 2's right here, which can be placed in the array as 2, 4, 2, which follows the pattern 2 to the squared equals 4. Hence, the answer is 3. So, once again, 3 comes because we want the maximum number of elements in the subset, right? And so if this is the subset, this has 3 elements. Now, this fits the requirements because 2 would be like x, then 4 would be x squared, and then we come back down from back to x divided, or x2, x, or not x2, just x, boom. So it's like we went up to here and then we came back here, only because the array we're dealing with is not this long, right? But it went up from x to x squared, then it came down from x squared to x, and that's what happened right here, boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input nums equals an array of integers 1, 3, 2, 4. This time the output is 1. It says we can select the subset 1, which can be placed in the array as 1, which follows the pattern. Hence, the answer is 1. Note that we could also have selected 2, 3, or 4. There may be multiple subsets which provide the same answer. So in this case, we're just picking one element, and that is our subset, and we could create that subset with any one of these elements to fit the requirement, since we're only dealing with one element to begin with. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we need to do is we need to count the frequency of every number in the array, and we'll use these frequencies to determine how long of a valid sequence we can build. So we'll declare a variable called dict colon square bracket. It's going to be a dictionary, so int colon int. Come outside of that, and we'll initialize it with a blank dictionary like so. Boom. Then we're going to say for num and nums. We're going to open up the bracket, and we're going to say dict square bracket num comma default colon 0. Come outside of that, and we'll say plus equals 1. So each time we see this num right here, we'll store it in dict over here, and we're going to keep count right here, right? That's what this value is. Boom. Each time we're going to start the count from 0. Each time we see this num, we're going to add plus 1. Boom. Now, we're going to come underneath this for loop, and we're going to say let ones equal dict square bracket 1 comma default colon 0. Then we'll come underneath that, and we'll declare a variable called res. We'll set that equal to ones mod 2 equals 0 question mark ones minus 1 or ones. Boom. So if 1's mod 2 equals 0, if that's true, we'll return 1's minus 1. If it's false, we'll return 1's, right? Boom. So then we'll come underneath this, and we're going to try using every distinct number as the center start of a potential chain. So we'll say for num in dict dot keys. We'll open up the brackets, and if since 1 was already handled, we'll say guard num exclamation point equals, so does not equal 1, else we'll open up the brackets and we will continue. Then the length of the chain built from this starting value, we're going to store that here by declaring a variable called count, set that equal to 0. Then we need a local copy because we'll repeatedly square it, so we'll declare a variable called num, set that equal to num. And while there are at least 2 copies of the current value, we can place 1 copy on the left side and 1 copy on the right side of the sequence, contributing 2 elements to a symmetric chain. So we'll come underneath this and we'll say while let f equals dict square bracket num, come outside of that, comma, f is greater than 1. We'll open up the brackets, we'll say count plus equals 2. Come underneath that, we'll say num times equals num. Boom. Then we've reached the first value that does not have at least 2 copies. If it exists once, it can serve as the middle element of the chain, contributing +1. Otherwise, we've overcounted the last pair expansions, so subtract 1 to make the length valid. So we'll come underneath this and we'll say count plus equals dict square bracket num, come outside of that, does not equal nil, question mark 1, colon -1. Boom. Then we need to keep track of the best chain length found by coming underneath this. We'll say res equals max, open up the parentheses, res, comma, count. And then finally, we could just come down here and we can say return res, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs. Oh, we got an error. So let's see what's going on. This should only have 1 equal sign here, I believe. Oh, actually, sorry, y'all. This should be a plus equal sign. Oops. So now let's give it a run, see if that fixed it. It's accepted, so let's go ahead and submit it and make sure it's still accepted after we submit it. Boom, and look at that, y'all. 39 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.